In today's video, we're going to discuss similar figures in a little more detail. We were introduced to similar figures during the dilation video. Here are our vocabulary terms for this lesson. Similar figures. These are figures that have the same shape but not necessarily the same size. Corresponding sides. These are sides that have the same relative positions in geometric figures. Corresponding angles are angles that have the same relative positions in geometric figures. And a scale factor, this is the ratio of any two corresponding lengths of the sides of two similar figures. Here are some examples of similar figures. We can see that in both examples we have triangles that are the same shape but different sizes. And notice both examples are triangles, but the one example on the left, the two triangles are exactly the same shape. They're both right triangles, just different size. And the one on the right, these are both obtuse triangles, but just different sizes. We also need to discuss a new mathematical symbol. This squiggly line that you see means similar to. If you look in the top right example, you would read that top phrase as triangle ABC is similar to triangle DEF. This is important to remember that this symbol means similar. When two figures are similar, there is a ratio for their sides, and their angles are the same. We call these corresponding sides and corresponding angles. In this illustration, we see that triangle ABC is similar to triangle XYZ. We can make marks on our triangles to show that our corresponding sides and corresponding angles. I will first show the corresponding sides. We see that the side here for AC is similar to the side for XZ. Notice I drew just one line. For side AB, I would notate that with two lines that is similar to XY. And you can probably already figure out what side BC would be. We can do that with three lines, and that is similar to side YZ. We can also tell this by looking at the order of letters in our mathematical phrase about being similar. Notice AB is the first two letters. That would correspond with XY. So side AB corresponds with side XY. Take a moment to see if you can use the letters to figure out another pair of corresponding sides. You might see that BC corresponds with YZ. So I could write that as such. To notate corresponding angles, we do something similar that we did with corresponding sides. I'll draw a little loop here. So that's my first corresponding angle. For the second one, I would draw two little half circles. And for the last one, I would draw three. And I see that angle A corresponds to angle X. And we also learned that these are the same size, the same degree, so I could actually write the symbol for congruent, which is an equal sign with the squiggly above it. So I also know that angle B is congruent to which one? Angle Y. And again, I can match up the letters at the top. Here's an example of how we can work with similar figures. I see that triangle DEF is similar to triangle RST. That means side DE corresponds to side RS, and you can go through and name all the corresponding sides and angles. With similar figures, you're either going to be asked to find a missing side or missing angles. We'll first look at missing sides. The first question may say, what is the length of side DE? Well, I see that this is DE, so I need to find what y equals. I do this by setting up a proportion. And you're going to set up a proportion by using corresponding sides. So the first one I'm going to look at is, I need to know what y is. Now what side corresponds with that on the other triangle? Well, hopefully you see that it's side RS, which is 3. Now I need to set up a proportion with some other sides I know. So let's find the 2 corresponding sides I know. I wouldn't want to use 4 and x, so I would use the other one. Since in my first fraction I started with the triangle on the left, I need to start with the triangle on the left for my second fraction. And I'm going to go with 8. Now what side corresponds with that? 4. And now I solve this proportion. If you remember how to solve a proportion, you cross multiply. So y times 4 is 4y. 3 times 8 is 24. I divide by 4, and I see that y is 6. So y is 6. Now let's do the same thing to find x. I'm going to set up my proportion. X corresponds with, if I look to the triangle to the left, I see it corresponds with 4. And now I can pick 2 other corresponding sides. For this one, I'm going to pick side 3 on the left, because I started with the left triangle, or excuse me, on the right, because in my first fraction, I started with the right triangle. So, my second fraction, I'm going to start with the right triangle. What corresponds with that? That would be 6. So let's cross multiply. X times 6 is 6x. 3 times 4 is 12. Divide by 6. X equals 2. So right here, x equals 2. And I have found missing sides of similar figures. If it asks you about angles, say it says angle F is 60 degrees, and it wants to know what angle T is. Well, angles are exactly the same, so this would be 60 degrees. If angle D is 70 degrees, that means angle R will be 70 degrees. Now what if this is all I gave you and wanted to find angle E? You need to remember that triangles, the angles add up to 180 degrees. So if you added 60 and 70, you would see that that's 130, which means the missing angle is 50 degrees, and that would be the same for both. Sometimes when you have similar figures, they may not be in the same position. If you look closely, you should notice that the figure on the right has been rotated to a different position than the figure on the left. Looking at the top, we see that they're similar because KLMN is similar to HEFG. So we still set up a proportion and find our missing sides. Let's start with x. Our first proportion will be x over, well, what side corresponds with x? I see that x is side LM, so looking over at the other ones, I see that it corresponds with EF, so that would be 7. Okay, now let's look and see what other corresponding sides we have. I see that KL corresponds with HE. Since I started with the left figure in the first fraction, I start with the left figure, which would be 90 over HE is 10. And you know what to do now, you cross multiply. 10 times x is 10x. 7 times 90. Well, I think 7 times 9 is 63, so I add a 0, which would be 630. Divide by 10, and I see that x equals 63. So the missing side for x is 63. Now let's find y. So set up our first proportion. Y corresponds with 36. And then I can set up another corresponding side. I can use 10 and 90 again, or I can use 7 and 63. Either one is fine. I'm going to use 7 and 63. When I cross multiply, I get 63y equals 252 divided by 63. And if I divided that out, I would see y equals 4. So up here, y equals 4. And I have found my missing sides. And remember, if it asks you about angles, all angles on similar figures are congruent. They're the same. So if angle N is 75, that means angle G is 75, and so on. This concludes our lesson on similar figures. If you have any questions, feel free to email me at robert.donaldson@hallco.org, or you can find me on Twitter. My username is @Mr_Donaldson. Until next time, thanks for watching.